Hello again, this is Mr. White.
And Mr. Curvis?
Today, for this podcast, we're going to talk about a rational function, this g of x rational function. And rational mean ratio. It's a function that's basically a fraction. So a couple of different questions that are typically asked. One are, of course, the y-intercepts and x-intercepts, and max and min, and then the asymptotes. Asymptotes are going to always be asked with these rational functions because there's lots of interesting asymptotes. And then domain and range, and we'll find an intercept too with another function. So we're actually assuming we're going to do this problem twice. We're going to do this problem with a calculator, and we're going to do it with a non-calculator. So if you find yourself answering a question like this with a calculator in hand, this is what you should do. So the first thing, we're going to type in the function on the top. Make sure you have parentheses, or it'll be completely different function. So the entire top needs to be in parentheses. Divide the entire bottom in parentheses. Okay. So that's actually a pretty good graph. Maybe a little bit more on the y. Okay.
Right, then just be a little bit careful, those vertical lines drawn in. If you're going to draw them as a sketch on the exam, make sure you draw them as dotted lines because they're not part of the graph so much as they are asymptotes.
So I'm just going to drag this over here so we can actually work on it and draw on it. Okay, so this is, we're next going to be solving for this y-intercept right here. It happens once. So how do I do that on the calculator, Mr. Curvis?
There's a specific menu that has nearly everything that we use for this problem, and it's under trace. So second trace gets you the calc menu, and in the first case we want to find the value when x is equal to 0. That will give you the y-intercept.
So it literally just asks me what x do you want, and the output will be the y value. So of course the y-intercept happens when x is 0. Just type in 0, and there we have it. It's 8.8 1/3, so 8.33 for 3 sig figs. So you have to remember to make sure you answer the actual question. Sometimes they say write as a coordinate. Sometimes they write what the value is. Just to make sure, write it as a coordinate unless they say otherwise. So 8.33. Okay. X-intercepts.
Good, so back in that same menu, but now we are looking for the zeros of the function.
These x-intercepts, they can be called lots of things. They're called x-intercepts, of course. Zeros is another popular name, and roots. So all of those terms you should be familiar with, and they're interchangeable. So, but the calculator menu says 0, so that's what we use. Okay, so I just can scroll over. It asks me a question. It says go to the left side of the function, and if you can see right here, you can pretend there's like a vertical line drop down on the function when it crosses the x-axis, and that's what the calculator means. Anything over here is the left side, and anything over here is the right side. So it's asking me right here. You can see it right there. I'm on the left side. So am I on the left side? Yes. So you push enter. And then it says go to the right side. And you can see right here it just put an arrow. Okay, it must be to the right of that arrow. So go to the right side of the 0 or the root. And see, it's asking you, is it between these two arrows? Can I guess now? Yes, you can. And the x-intercept is 5. So let's write it as a coordinate. 5, 0.
Good, so you have the x-intercept or the 0 or the solution on the right-hand side, and you repeat that process on the left.
Okay, so let's just do it real quick. And we get 0, scroll over. So I have to be to the left. So I have to go over here first. Left. Right. Enter. -5.
Good. So x-intercept's found, y-intercept is found, maximum and minimum. According to this graph, we have one minimum. There's a global minimum, of course, all the way down. It just keeps going and going. But this is what we're interested in here.
Yeah, that's an important point that Mr. Kurbis brings up. There's lots of different types of minimums. We call this a relative minimum, even though that the function goes down to negative infinity on both of these sides here. But this is still technically called a minimum, and by definition, it just means when the function starts to decrease and goes to increasing again, and that's all what a minimum means. So we need this guy right here. Okay, how do I do that, Mr. Kurbis?
Same menu again, second calc, and now we want number 3. And it's a similar process with the left bounding and right bounding.
Yeah, it asks me actually the same question, and I have to go to the left of the minimum, like that, and I can go to the right, and it doesn't matter if I cross the axes, it doesn't matter. And it asks me the question, can I guess? And yes, so we get negative 0.6. How do we write that? 3 sig figs.
670.
Comma 7.89.
Yeah.
Good. Okay. Domain and range. All right. So the domain is what numbers I can put into the function and actually get an answer. So the domain is, well, we need to find that vertical asymptote, don't we?
So the domain will be all real numbers with the exception of the asymptotes. On the next podcast, we will go through this algebraically and we'll break down the asymptotes, the domain and range more specifically.
Okay. So we will stay tuned to that next part. We're going to do all that algebraically. And then the range, we'll do the same thing. So stay tuned to the next podcast.
Okay, but what we will look at is part C here, which is given f of x equals 2x plus 10. How do you solve for where that is equal to our function?
Okay.
And I've actually just made a little mistake there in the type up. It should say, no, that's right. Never mind, f of x equals g of x. So 2x plus 10.
So it's not a hard problem. It's just asking you literally, where do these functions meet? Where do they touch each other? Where are they equal? So just throw it in there, and we'll find out where they're equal. It looks like there's 1, 2, 3 intersections, and this is not an intersection right here. So what if we say we get rid of this graph actually?
That's a pretty big eraser.
It sure is. And get rid of this one, and so we can label these intersections.
Okay, and for the sake of time, what we will do is we'll just find one of these for you, and then we'll stop the podcast and just go through that same process 2 more times to find the other intersection points. You will need to find all 3 on an exam.
Yeah, so our answers are here, here, and here, and these guys right here are not intersections. These are asymptotes. It's actually not on the function at all. Yeah, so, okay, run through it one time with me, Mr. Kurbis.
Okay, same menu, second trace. Now we're looking for number 5. Where the 2 functions intersect, they have the same x and y value, and that's what we're interested in when you're solving.
Up and down, I can switch between the functions. So for some reason, you've got f and g and h. Yeah, you can switch up and down between the functions. Plus, it's easier if you're scrolling across a linear. All you really need to do is get close to the function. It says, asks you a question. First curve? Yeah, sure. Second curve? Yes. Third curve? Or can I guess now? Yes. It's just enter, enter, enter. So we have our intersection here is -5, 0 right there. And do that 2 more times for the others. Thank you very much. Stay tuned to the next for the algebraic version of the same problem.